ruminants is stored in? Your options are: is it the liver, is it the gallbladder, or is it the rumen, or is it the esophagus? Where is it stored?
Sir, Roman.
What about
Rumen.
that? Is rumen? Okay, na? Okay, good. Also tell me, I'm asking a question from some other chapters as well. Okay, now then we are going to continue with what we have discussed. What is the relationship that we see in the alga and fungi? So is that relationship a parasitic, like a symbiotic, saprophytic? What kind of relationship is seen?
So symbiotic. So
Okay, what about you, Prinka?
Yes, sir.
That is symbiotic. Okay, very good. Okay, also tell me that like as a cleaning agent, which base you guys can use? Will you be using magnesium hydroxide or calcium hydroxide or sodium hydroxide or ammonium hydroxide as a cleaning agent? I'm asking, in order to clean the different things. Let me
Sir,
write
sodium hydroxide.
let me write down the options once again. Ammonium hydroxide, think about it once again. It is not correct, by the way. Okay, na?
Okay, sir.
Sodium hydroxide, or is it ammonium hydroxide, or is it calcium hydroxide, or is it magnesium hydroxide? Which one of these you guys will be using? Which one of these can be used as a cleaning agent?
calcium hydroxide.
No. In fact, a question of similar nature has been discussed in the previous class. Remember the milk of magnesia and the window cleaner example, the question?
Yes.
Uh, it's ammonium hydroxide, guys. Yes, Priyanka? In fact, you answered the same question you answered in the previous class, I think, Priyanka. For
Yes,
the
sir.
window cleaner, you wrote that in the chat box.
Yes, sir. Yes, sir.
Okay, no?
Like, I was like confused about it, the question, right, sir?
Okay, okay. No issues, no issues. Okay. Do tell me what will happen if I were to take a solution of baking soda and put it on a turmeric paper. You know, turmeric papers are also made, by the way. Turmeric papers are also made. So what if I were to take a turmeric paper? I were to take a baking soda solution and put that on a turmeric paper. What would you observe? Will the color of the turmeric paper change from yellow to blue, yellow to green, yellow to red, or yellow to magenta color? From yellow color, the color, will it change to red? Will it change to magenta color? Or will it change to pink color? Or will it change to green color?
Sir, red color.
What about you, Cos? Cos, what do you think?
Um, so baking soda is a base, but I don't know the color change. Sir.
Actually, like we did learn there in the class. If you were there, I suppose, I think you were not there. Basically, what happens when we take a baking soda solution and when you drop some baking soda solution on a turmeric paper is yellow in color. Now, I have mistakenly drawn it.
Yes.
This it is red, yellow in color. So its color changes to red actually. Getting it now? So thereby
Yes.
indicating the presence of base, like that this substance is a base. But in acidic solution, it remains yellow. Okay.
Okay, sir.
Okay. One more question from the chapter here I would like to ask. You guys tell me. Uh, you guys know about the flask, right now? The flask in which
Yeah,
water
thermos.
thermos flask, exactly. So the vacuum that is present in the flask, it will be reducing the heat transfer by convection or by conduction and convection or by radiation or by conduction. Let me write down the options, it will be more better. So the question, the vacuum present in a vacuum flask reduces heat transfer or reduces heat loss by convection or by both conduction and convection, or is it by radiation? or is it by radiation, or is it only conduction? Think about this carefully and answer this. Yes, what do you guys think of this?
Sir, can you write the question too?
Okay, sure. Let me write down the question. The vacuum present in the glass flask, uh, reduces the heat loss by reduces the heat loss by. Were you guys there while we were revising the chapter heat? Were you guys there? I think it's from a different class, so you guys might not be there.
Yes, sir. But then we learned.
Yeah, exactly. We had learned about this in the previous classes. We had learned about this. Okay, na? Anyways, yes. Okay, should I help then? See, basically the thing is that for the transfer of heat via radiation, we know that it does not require any medium. Okay, na? It can the heat via radiation can transfer through vacuum also. Okay, but for the transfer of heat via conduction and convection, a medium is required or not? It is required, no?
Yes, sir.
Okay, so you have removed the medium here. This yellow color here, it represents, let's say, it represents a vacuum here. It represents vacuum. So since there is no medium, so the transfer of heat via convection and conduction is not going to take place. So heat is not going to travel from the flask to the outside environment because there is vacuum present between the two vessels, between the two layers of the vessel here. Okay, na? So appropriate option is option number B. Okay, na? So we prevent the loss of heat both via the conduction and the convection mode here. Okay, na? Hope it should be clear.
Yes, sir.
Okay. Answer one simple question to me. What is the purpose of or just answer this question to me. Like how do earthworms increase the soil fertility? Yes. How do earthworms increase the soil fertility? Yes. Or otherwise, you can answer this question to me. That what is neutralization?
Yes, sir.
Mm-hmm. Answer any of the questions, guys.
Sir,
Yeah.
Neutralization is the reaction when a acid and a base when an acid reacts completely with a base to form salt and water. Example, hydrochloric acid plus sodium hydroxide is equal to sodium chloride plus H2O.
Very good. Very good. Okay. Also, we know that, like in the case of the earthworms, they are called as farmer's friend. As they would be moving inside the soil, so they would be creating a small burrows inside the soil, creating gaps between the soil particles. So thereby, in between those gaps between the soil particles, air molecules can enter. Hence, the roots of the plants can breathe, and the microorganisms can also have access to oxygen. So thereby, it will be increasing the fertility of the soil. Getting it, right? Increasing the quality of soil. That's the thing. Okay. Okay, let's start with what we're doing in the chapter. The batch, the motion and time was going on. Abu Bakr tried to join the class on given time. So in the chapter motion and time, so far we have learned about some of the interesting concepts, like when a body will be really said to be in a state of motion. By the way, all of you turn your cameras on in the class. So there we learned, in order to say that an object is in a state of motion, we have to consider several things. We have to consider its position with respect to time. We have to take help of a reference object, or we did also discuss about the observing body, observe about an observer also. Right now, for example, we had an example like this: bus is said to be in a state of motion with the change in time if it changes its position from position A to B. If it goes to position B after some time, so it must have taken some time, okay, na, in changing the position. So an object is being said to be in a state of motion. This bus is being said to be in a state of motion because it is changing its position with respect to time. The time is also changing. Earlier it was 5 p.m., now it is 6 p.m. So it took some time. Plus, we took help of a reference object also. So this is stationary pole, which is at a rest, which is not moving, it acts as a reference point. That is one thing. Furthermore, we learned that the passengers that are sitting inside the bus, when they look at each other, they are in a state of rest. They are not moving inside the bus. But when an observer is standing outside the bus, he will say that actually the bus, along with the passengers that are inside the bus, all of them are in a state of motion because they are changing their position. Okay, now? But the co-passengers inside the bus, they are in a state of rest to each other. We had this classic example of the earth, the moon also, where on earth right now, with respect to earth, we are in a state of rest, we are not moving. But when an astronaut from any other exoplanet, from any other planet will look at us, he will see that all the persons, all the people on the earth, along with the earth, all of them are in a state of movement, all of them are in a state of motion because they are doing revolution around the sun. In fact, sun is also not stationary. Sun also is doing revolution of the galaxy. Getting it now? It is also doing revolution in the universe. So in fact, every object in the universe is in a state of motion. Getting it, guys? But don't write down definition in that manner. Otherwise, you like we don't say that any object is in a state of absolute rest. Nothing is absolute at nothing as is nothing object is at a state of absolute rest. Absolute rest means that it does not changes its position with respect to its surrounding, no matter from where you are observing it. Okay, now from where you are observing it. But in the case of the earth, whether you observe it from moon, whether you observe it from Jupiter, or whether you went to another galaxy, so you will still see that the earth is moving. Okay, in fact, the very object, the very planet from where you will be observing the earth, that planet will also be moving. So everything is in a state of motion actually. Getting it on the wide concept I'm trying to explain. We learned about distance. Distance is nothing but the total path covered by an object in a given interval of time. We learned about how it can be calculated by the formula speed multiplied with time. It can be calculated. SI unit of distance is usually meter. The bigger SI unit of distance is kilometer. Talking about the displacement was the shortest distance between any given 2 points here. Okay, now that is the thing. Further, we were learning about the different types of motions. There we had learned about the rectilinear motion, circular motion, periodic and oscillatory motion. We were currently discussing about the oscillatory motion in the previous class. Okay, now. So in the case of oscillatory motion, we had several examples. One of the classic example is the simple pendulum. Okay. So in the case of simple pendulum, what happens? Let me just clean this. So in the case of a simple pendulum, this structure is being called as bob. This structure, this metallic ball is called as bob. So when this metallic bob is going to move from one extreme position to another extreme position, or let's say that it moves from position A to B and goes from B to C, and then again goes from C to A, then it is said to have done one oscillation. It is said to have done one oscillation. Getting it, Priyanka, Abu Bakr, and Gauss? Hmm?
Yes, sir.
So when the bob of a simple pendulum moves from its mean position, okay, mean position, B to A and back to B again, then from B to C and back to B again, the pendulum is said to complete one oscillation. Let me just put it in simple terms. It basically is going to move in this manner. It goes from B to A, or goes from B to A, B to C, I mean to say, and comes back to A. So it started its movement from the rest position, from the central position where it was at rest, then went to this extreme position B, and then went to another extreme position C and came back to A. So then it is said to have done one oscillation is completed here. Okay, that is one thing. Further, this must have taken some time now to complete this one oscillation. It must have taken some time. Okay, so the time period is basically the total time taken by the pendulum to complete one oscillation. Whatever time it took to complete that oscillation, it is the time period. So that is the oscillation and time period of this pendulum. Hope you guys are getting this. Okay.
Yes, sir.
Okay. Now let us understand like how we can calculate this. We have so many questions based on this which we can calculate. Okay. By the way, one more important thing is like this kind of movement that is being done by the bob of the pendulum, that is the forward and the backward movement, to and fro movement, that is called as oscillatory movement. Oscillatory movement. And oscillatory movement is kind of a periodic movement. Okay, now where a particular kind of motion repeats after a period of time, after an interval of time. We had several examples of periodic movement. Yes, Priyanka, in the previous class, you guys listed several examples of periodic movement, like the revolution and rotation of the earth. It's a periodic movement because the particular type of motion is completed in a given interval of time and it repeats every time. I mean to say, let us say that this bob takes 1 second to complete one oscillation. So after 1 second, it is again going to do the same kind of movement, move from A to B, B to C, and C to A. That's the second. Then after the third second, again it is going to do the same kind of movement now. So this comes under the periodic movement. This is a type of periodic movement. Okay, now it's a type of periodic movement. Okay, now so periodic movement is any movement that repeats itself after a certain period of time. Okay, now so periodic movement will be like the rotation of the earth on its axis, revolution of the earth around the sun, the seesaw, uh, or we have the example of like this one, oscillatory movement that is being done here. So oscillatory movement is one of the type of periodic movement. Why we are calling this as a type of periodic movement? Because periodic movement is any movement that will repeat the same motion after a given interval of time. An oscillating movement is what? When an object moves to and fro, moves forward and backward. We have the example of tuning fork. Okay, now in the physics lab, you might find the tuning fork that looks like this. So take a tuning fork and struck it on any surface. The fork is going to vibrate like this. It is going to come here and then here. It is going to vibrate like this. So that is the case. Okay. Okay, let's do some questions on this. Okay, now. Okay. Uh, Let us say that. First of all, let me give you the formulas, the important formulas here. Okay, now talking about the time period and the frequency. Just one more thing to be, that is frequency. Okay, time period is basically nothing but the time taken by the pendulum to do oscillations, to complete one oscillation. That will be called as the time period. Getting it, guys? The time taken by the pendulum bob to complete one oscillation, that is called as time period. Okay, let us say, for example, this pendulum bob might have taken, let's say, 1 second to complete one oscillation. So that 1 second is the time period of this. Okay, now that is one thing. But what if it is completely doing, let us say that it does so many oscillations. Right now, for one oscillation, the time taken was 1 second. But what if it is doing, let's say, 10 oscillations, 20 oscillations, and it took, let's say, 5 second, it took 8 second. So then how are you going to find the time period? Because by definition, time period is the time taken by the pendulum to complete one oscillation now. But how many oscillations are there?
10,
10. How many oscillations are here? 20 now.
20.
By definition, Gauss, Abu Bakr and Priyanka, it means the time taken to complete one oscillation. So you are going to divide the total number of oscillation with total time here to find the time period, isn't it? Simple
Yes.
maths now.
So,
Understood?
sir, so
Yes.
10 divided by 5 or no, 5 divided by 10,
Yes.
we should divide it, right?
Yeah, we have to divide this basically. Okay, no?
By 5 divided by 10, right?
We'll be doing some questions on this. Okay, and that will be giving you a better conceptual clarity. Okay.
Okay, sir.
So let us take a question here. Okay. Say that there is a simple pendulum that takes 32 seconds to complete 20 oscillations. A simple pendulum takes 32 seconds to complete 20 oscillations. Okay. We have to find the time period. What is the time period of the pendulum? First, you guys try it, and then I will be helping and I will be telling the formula as well. First of all, try to use the logic here and try to do it. Anyone of you getting the answer?
No, sir.
No? Gauss, what about you, Abu Bakr?
Sir, maybe I will understand the answer. I will know the answer, but I do not understand the question.
Okay, okay. Okay, I think I'll be required to help here. Okay, let's understand it. Now, guys, time taken by pendulum to complete 20 oscillations. How much time is taken here?
32 seconds.
32 seconds. Okay. So further tell me the time taken by the pendulum to complete one oscillation will be what? Complete one oscillation will be what? In mathematics, you would have learned about the linear equations and all that. So that is simply 32 upon 20 now. 32 upon 20 second. That is 1.6 second. Yes.
Yes, sir.
So it's the same question. Like for example, say that uh, 12 pens cost 180 rupees. So what will be the cost of one pen? The question is 12 pens cost 180 rupees. Find the cost of one pen. What do you guys do then? Find the cost of one pen. No. What do you do then? You solve it in the following manner now. Whatever is given in the question, first of all, you write down right now. So you write the cost of 12 pen according to the question is 180. So cost of one pen will be 180 upon 12, and that is 15 rupees now.
Yes, sir.
Got this, everyone? So that is how we solve this. So what formula do we get? in order to calculate the oscillation, what is written over here? 32 is the time here now. 20 is the number of oscillation. So time period is
Sir,
calculated. Yeah.
sir, so the time period taken upon number of oscillations.
Total time taken. Total time
Yes.
taken upon the total number of oscillations. That and that is how you find out the time period. Getting it? No? So time period. Write down the formula. Time period equals to total time taken divided by total oscillation done, or basically the number of oscillation that is done by the given pendulum. Number of oscillations. Okay, so that is it. Okay, next we have the concept of frequency. Frequency says the opposite. Frequency talks about the number of oscillations done in a given second. What it is, it says how many oscillations are done in just 1 second, not 2, not 3, not 5, on in 1 second. So that is the frequency. Okay, so frequency talks about number of oscillations done in 1 second. Number of oscillations done in 1 second. Getting it now? Or basically we calculate in terms of, like, we calculate a unit value for this. Okay, now let us do a question and that will be clearing it out. Okay, the definition is clear now. You guys are understanding now what the frequency of a simple pendulum is.
Yes, sir.
It's nothing but the number of oscillations that it will be doing in a per unit time. Like in per unit, like it's 1 second. Okay, now. Okay, interestingly, there's a relationship between the frequency and the time period. Okay, but for that, before that, I let us learn the formula first of all. 1 minute. Now, so the formula of the frequency is basically number of oscillations upon time taken. Now, can you guys spot any difference here? Is there any difference? Basically, it's the reciprocal. Now, frequency is the reciprocal of time period. Can't we say that? You guys understand about reciprocal now? When you inverse the order of the numerator and denominator, that becomes a reciprocal of
Yes,
any
sir.
given number. Exactly.
Yes, sir.
So here numerator was here. Now the numerator goes to the denominator here. Total time taken. Now here's the time taken. So frequency is inverse of time period. Whatever you guys are getting in the time period, if you were to inverse it, you will find the frequency. So there is a relationship between the frequency and time period, and that is represented by this. Let me take an empty slide here. So frequency equals to 1 upon time period. 1 upon time period. In fact, write down this thing. Okay, now. So it was nothing but the number of oscillation it makes in per unit period of time, or basically in per second. Furthermore, frequency is measured in hertz. Frequency is measured in hertz. In hertz and represented in short as capital H small z. You guys done?
Sir, is it like is it same as the sound frequencies like?
Frequency of the sound. Yeah, it's the same thing basically. Okay, now basically same thing. Okay.
Okay.
Let's do some question on this. Okay. A pendulum does 25 oscillations in 12 seconds. Find the frequency. Find the frequency. I'm giving one more question here. In this school, by the way, questions have been practiced on this or not, Priyanka? Yes, Priyanka?
Sir,
Mm-hmm.
for the which one, sir?
Like you have practice questions on time period of frequency in the school, or very present at that time when this was going on in the school?
Sir?
Yeah.
Sir, actually, I don't know.
Okay. Anyways, but in the class you're getting it now. You're understanding it now.
Yes, sir.
Very
It's
good.
like we learned about the time period,
Mm-hmm. But
time take, number of.
okay. That's good. What is the time period of the pendulum? That is the question. What answer you guys are getting for the previous question?
Sir, can you wait 1 minute? I'm doing it.
Oh, okay. Sure. Others can answer in the chat box. Meanwhile, they can answer in the chat box. Anyone who has got the answer? Abu Bakr, are you facing difficulty in this? Okay, cause. Just recall the formula. Should I write down the formula here if you're facing a difficulty? Yes.
Sir, we should divide it only, right?
Of course, in both the questions, you have to do division. But recall the formula. See, what formula? Take the help of these formulas here. In order to find time period, it's total time taken upon the number of oscillations that is being done. For frequency, it is opposite. Number of oscillation upon time taken. Okay, now. So time period, it is time upon the number of oscillations. For frequency, it is the total oscillation. I'm writing in short here. Okay, now. It's the total oscillation upon total time.
So, sir, in this we should find frequency, right?
Yeah, you should have. Yeah, that is correct, Gauss. You have to find the frequency for the first question. It's mentioned here. Find the frequency.
Yes, sir.
Hmm. Abu Bakr, what about you? Facing difficulty in this? Like even if this chapter is not there in the syllabus now, I'm telling this that this concept is important and helpful, going to be helpful for you in the in the upcoming classes, Abu Bakr. Okay, now. So you also solve these questions because you're getting this answer for the second one. Oh, Priyanka, how can you be getting such a big number? What have you done? Okay. Okay, now you're writing it. Okay. In decimal, it will be 2 point something. Okay, na 2.0 something. Okay.
Yes, sir.
Hmm. Nonetheless, you can take the estimated value to be 2. Okay. And for the second one, was you are getting 0.333. I'm afraid that there might be something wrong in this. Okay. It will not be 0.333 was okay now. So redo the second one. Take the help of the formula. It's mentioned here. Time period is calculated by dividing the total time taken upon the number of oscillation that is done by the simple pendulum. Abu Bakr, you there in the class? You haven't solved any questions so far?
Sir, I have solved first one. I'm doing the second.
Oh, okay, okay. Was redo the second question. Yeah, for the second one, Priyanka and Gauss, your answer is correct. Okay, now like whenever you write down the answer, no Priyanka, make sure that when you write down the question number, put a dot after it like this. Okay, no.
Okay, sir.
Otherwise,
Right.
sometimes it might be confusing.
So can we do more frequency questions?
Yeah, sure. Let us take some more questions. I'm going to change the slide for a while. Okay. Question is: a pendulum does 38 oscillations in 2.8 second. Find time period. Find time period and oscillation both. I mean to say a frequency. Find time period and frequency. Now I'm going to twist the question. I'm going to give a twisted question. Okay. Say that the time period of a pendulum is 2 seconds. What is its frequency? What is its frequency? Meanwhile, Abu Bakr, you done with the previous questions? Abu Bakr, you done with these questions? Yes or no? See, for the question number 1 here, the answer is about 2.0 something. Yeah, you're saying something.
Sir, I got 2.
2. Okay, estimated value 2, that is correct. All of you gave the answer 2, that is good. And for question number 2, it is?
4.
How can it be 4? It's simply 15 upon 5 now. Getting it? What did you had to calculate? You
Yes,
had
sir,
to
I cannot
calculate
I,
time period, no? Time period equals to total number
sir,
of time upon oscillation. So thereby it is 3, okay, no? Now I have given these questions, okay? So a pendulum does 38 oscillations
I
in
did
2
not
point.
get 4. I got
Abu Bakr,
5.
speak.
Sir, I did not get 4, I got 5.
You
Sir,
got
because the answer I got is 3.333.
no, that should not be the answer. The pendulum is taking 15 seconds here, and it does 5 oscillation in that period of time. So 15 upon 5 will be simply 3. Okay, not 3.33, not like that. Simply the whole number 3.
I rounded off to 4, but then
No,
I had to round it up to 3.
no, why just need to do much type of calculations? It's simple enough. 15 upon 5, that is 3. Now you can solve this question. The pendulum is doing 38 oscillations in 2.8 seconds. Find the time period and frequency. What is the relation between frequency and time period? They share a inverse relation. Getting it now? And that relation we had denoted as follows: f equals to 1 upon time period. Okay, now f for frequency, t for time period. Keep that thing in mind while solving the second question here. So I've already given a hint, in fact. Gauss and Priyanka and Abu Bakr, any update on first question?
Sir,
Yes.
we should take off the point, right?
While division, you will be taking out the point. You have to remove the decimal while division. Gauss, are you facing difficulty in question number 1?
No, sir, I'm just solving question 2, sir.
Okay, okay, good. Yeah, you have to find both of them, Priyanka. Question number 1, you have to find the time period and frequency
Yes,
both.
sir. For the time period, is it correct?
You're getting this value. No, it is not correct. No. The number is 38 and 2.8. So that answer is not correct. Okay, now?
Okay,
Okay.
sir.
Kindly check the division. Okay, you guys tell me. What is the formula for the time period? What did I told you guys? Hmm. Yes, Priyanka? Particularly, you
Sir,
tell me
for the time period,
hmm,
time divided by
number of oscillations. Okay. So it's a time taken to complete the number given number of oscillations. So number of oscillation. And for frequency, it's the opposite. It's the number of oscillations done in a given time. Okay, time taken. So you have all the things available here. You guys solve it quickly. For Gauss, you're getting frequency this and time period this. Okay, okay. Let me see. Yes, for the first one, it is correct. Was frequency you have find it out to be correct. Very good. Let me check for the time period as well. Others also solve this quickly. Abu Bakr and Priyanka. Was has already answered the first one, and it's correct by the way. We're getting about 0.0 something, no? Mm, that is correct. Yes, Gauss, your first answer is correct. Well done. Priyanka, okay, you have written only the whole number, not the decimal. Okay, that is correct, but you could have written 13 point something. Okay, no? Or let me, it will be 13 point 13.7 something, I mean to say. To be specific, 13 point, uh, no, not 7, 13.57 something. Okay, now? That is the frequency for the first question, guys. Getting it? Frequency here is 13.57. Now it is very easy to calculate time period once you have calculated frequency. What you have to do, you have to simply inverse it now, because we know frequency equals to 1 upon time period. Getting it? Frequency equals to 1 upon time period. So from this, if the frequency is given, can't I find out the time period? All of you pay attention here. If the frequency is already calculated here, so do I need to use this formula? Do I need to use this formula? Do I need to do all this lengthy process? No, there's just this thing like frequency is already given, so time period will be 1 upon frequency, and frequency is 13.57 now. Getting it, guys? So you can simplify this and you will be getting your answer. Abu Bakr, Was, and Priyanka, all of you getting this now what I'm trying to say here?
Yes, sir.
Very good. For the second one, who have got the answer for the second question? It's very simple.
So, but then there's not only there is 2 seconds.
Yeah, but we know about the relation also here now. Just right now, I explained this thing. Like the question says, yeah, the time period of a pendulum is 2 seconds. Here, what is its frequency? So if out of time period or out of these two, if any one thing is given, so you can find the other thing very easily now. Like for this question number one, I explained you have calculated the frequency, so you can easily calculate the time period, because with frequency equals to 1 upon time period, or whether I say that time period equals to 1 upon frequency, it's the same thing now, isn't it, guys? Like you would have learned about this thing, like if A equals to B upon C, so can't we also write down C equals to B upon A? C goes over here and A comes over here, right? Now C here was in division, here it went to multiplication, and there A from here came to division here. Was, are you not getting the second question, Abu Bakr and Priyanka? Kindly tell me, because we have to do other things in the class as well. No need to hesitate or feel shy if you're not getting the concept or facing difficulty in solving the question.
No, sir, I'm not getting.
Not getting it. Yeah, that's the thing, no? Okay. Let me help you guys here.
Same, sir.
Yeah. You should have told it earlier in a moment. So, like, you should have told this thing to me. Okay. For the question number one, the pendulum does 38 oscillations in 2.8 seconds. What you have to do, you have to find the time period. So total time taken here is 2.8 now, right? And the frequency oscillation is 38. Okay. So that's how you're going to calculate the time period. For frequency, You have to divide the number of oscillation by the time taken. How many oscillation is being done? It's 38 and time taken is 2.8. What do we do when we have to simplify this fraction in which one of the value is in decimal? Remove the decimal. In the numerator, it will be multiplied with 10. Right now? Further, in order to simplify it further, we can write it like this. 2 19s are 38. Okay. 2 14s are 28 multiplied 10 here. 2 cancel. So now we are left with 19 upon 14 multiplied with 10. By the way, you could have simplified this one also further, like 7 2s are 14. Okay, na 2 5s are 10 like this. So it would be 19 5s are 95 upon 7. Okay, na? So 13 7s are 91, isn't it? 13 7s are 91, isn't it, guys? So the answer will be 13 point something. Specifically, to be very specific, it's 13.57. So what frequency we are getting here? Frequency is exactly 13.57. Okay, now when you will do the complete division, you'll be getting this value. And what I told you about the time period, either you can carry out like this. You're going to remove the decimal, and in the denominator, it will be multiplied with 10. So this is now 28 upon 380. 28 upon 380. Getting it, guys? Okay. After simplification, this will be simply 7 upon 95, isn't it? Yeah. 7
Yes.
4s are 98 and 4 95s are 380. 7 4s are 28, 4 95s are 380. So we have written it 7 upon 95. Okay, so what answer you are going to get here? You are going to simply divide it further, and in terms of decimal, you will be getting some answer like Gauss got it 0.0736, and that is correct, in fact. Getting it, everyone? So this will be 0.076, 0736. Now, the problem where you guys had now, like you saw it as a decimal number, you thought of this as a very complicated question, but all that was required in this question was calculation. The only part that was difficult was the calculation, but the concept is easy now. Getting it, Gauss, Priyanka, Abubakar, everyone?
Yes.
Talking about the second question, you had to use this relation between frequency and time period, where I said you that if the time period is given, you can calculate the frequency, or if the frequency is given, you can calculate the time period. Okay, so the time period of a pendulum is 2 seconds here. The time period of a pendulum is 2 seconds. We know frequency equals to 1 upon time period, and here it's given the time period is 2. So 1 upon 2 is how much? It's 0.5 now. So the frequency is 0.5 hertz. As simple as that. Is it clear to everyone?
Okay.
Abu Bakr, you got the second question? And Priyanka?
Sir, with the frequency formula, will one always be on top? Like,
One will always be on top. It's a relation here, no? Like it's a relation. Frequency is the inverse of time period. When you inverse the time period, you get the frequency. I mean to say, like, for example, say, what is the reciprocal of 9? What's the reciprocal of 9? Everyone tell me, what's the reciprocal?
sir, the reciprocal of 9 is 1 by 9.
1 upon 9 exactly. Huh? Reciprocal of 11
Yes.
is 1 upon 11. So the
Yes, sir.
reciprocal of frequency is time period. So it will be 1 upon time period now, as simple as that.
Oh,
So
okay, sir.
understood. That's where this one came from actually, huh? Okay, no? So that is the thing. Another important thing is like we are going to learn about the speed. We have learned about the motion. Let me just revise some of the different motions. Okay, no? Like there's some particular kind of motion, like rotational motion is there. Hmm. So what do we know about the rotational motion? When an object would be moving in a circular path in from a fixed point with a fixed axis, so thereby it will be said to do a rotational motion. Like for example, you have a spinning top. So a spinning top is doing a circular motion about a fixed axis,
Yes, sir.
right? Or the Earth is also spinning on its axis, right now.
Yes.
So we have several examples of the rotational motion. So when an object would be moving about a fixed axis where all the parts of the object would be moving in a circular path. I mean to say that you have a spinning top. Say that you have a spinning top like this. So when it rotates, so all the part of the spinning top is rotating in a circular path. The body is moving in a circular path now,
Yes, sir.
but it is moving about this fixed iron nail. There's an iron nail in the middle, and that iron nail acts as the axis about which the all the part of this spinning top is moving. That is the case of the rotational motion. Hope you guys are getting it. So what are some other examples of rotational motion? Because
Sir, the earth spinning about its axis.
okay, and
Sir, a fidget spinner.
fidget spinner, good. Earth rotation, we have the example of uh, spinning top here. Spinning top.
Sir, what is fidget spinner?
Fidget spinner, like you guys would have seen this, like fidget spinner. Was explain what is a fidget spinner?
It's like a toy. It's like as a
Yes, sir.
Hmm. Kind
yeah.
of a
Yes.
small toy which you can rotate it on your fingers like this. Fidget spinner. Yeah, this is the fidget spinner. Getting it, guys? Abu Bakr?
Yes, sir. I've never seen it.
Okay, you haven't seen it. Okay, you might not have played with it, but this is like available online, or you can purchase it from any toy shop. So there it is available. Okay, na? Okay, we have some other examples also, like the Ferris wheel that also does a rotational motion. Now, Ferris wheel. Hmm. So this is the fixed axis of the Ferris wheel, isn't it? The fixed axis about which it is going to rotate. Getting it, guys? Now, so we have the example of Ferris wheel. What other
Sir,
examples do we have? Yes.
sir, what is the purpose of fidget spinner?
It's nothing but to just play. It's a toy to play. Okay, no? It doesn't serve any specific purpose. Okay, just for fun, just for yes,
Just spinning it.
just to spin, just like take it and just spin it. Okay, no? Just like this spinning top, just like it doesn't have any purpose. Just it's a toy to be played. Just in the similar fashion, similar manner, fidget spinners there. Okay, no? Or like you take a basketball and you spin it on your finger. So that also does a rotational motion, right now. Or the bicycle wheel, isn't that also an example, guys?
Yes, sir.
So bicycle wheel is also rotating about on its about the axis. Okay, na? So these are some of the bodies that are doing rotational motion. Got this, everyone?
Yes.
So hope this much is clear. We have so many things left to be discussed in the chapter. In the next class, now we would be learning about the speed. Okay, now in the next class, we'd be learning about the speed. We'd be learning about different types of speed: uniform speed, non-uniform speed, and how you can convert any given speed from kilometer per hour to meter per second. So the conversion is also left to be discussed. Okay, speedometer and odometer, I think everyone knows. What is the difference between the two, guys?
The speedometer like measures the speed
Hmm.
in kilometers per hour or miles per hour, like what the vehicle is traveling. And odometer measures
Hmm.
the total distance traveled by the vehicle.
Total distance that has been traveled by the vehicle so far. Okay, no? So that is the thing. Okay, so that's it for today. We'll be continuing from the next class. Okay,
Okay, sir. Thank you. Bye.
Mr. Welcome. Bye.
Sir.